Hello and welcome back to Programming with Adam. And in this video, we will be looking at LeetCode problems. So the next one is convert sorted array to binary search tree, number 108. So let's have a look at how it looks like. So this is the description. So basically convert a array like this into a balanced tree. And so plug in all the numbers into a balanced tree. So how do we do it? Well, that's the solution. And so let's look at the first two lines of the code. This is basically saying if the list is empty, then return the empty tree. Okay, so that's what we do. And then the idea is we cut the list in the middle. So so this is the length of the list nums and divided by 2. So this symbol is floor division, so it means rounded down. So let's look at an example we have here. If we did that, the length is 5. We divide by 2. That is 2.5, but we are rounding down to 2. So what will be the middle number? Well, it will be the number at index 2, which is 0. So exactly in the middle. So that works really, really well for lists of length for a list of length 5. And what about if we scratch the 9? Okay, so let's say we have a length of 4, then it will be 4 divided by 2, which is 2, and then well, that's just 2, so that would then be a 0. So in that case, notice in the worst case scenario, there can be one more element in the left side or the right side. But because the requirement here, the balanced tree is defined as a tree in which the depth of the two subtrees at every node differ by at most 1. So that's okay. So this could be like the 9. You see the problem, right? Maybe we're missing 1 at some point or not. So but other than that, we just kind of divide by 2, divide by 2, divide by 2 simply means we're trying to fill out the trees as much as possible, as symmetrically as possible. Okay, so that's why it works. So and then what we are returning, what we are returning, well, the value. So we are returning a tree node, right? What is its value? It's the number at the middle of the list, and then to what is to the left of that tree node. What is the left child? The left child, well, you simply take the left half of nums and you make that into a tree. And for the right child, you take the right half of the list nums and you make that into a tree. So because they have the same number because the two lists have the same number of elements, when the balanced trees will be very, very similar in depth. So that's why it works, and so on and so on. Okay, so that's the algorithm. Let's look at the performance, 99.51%. So there is just basically no way you can do this better. This is optimal. So okay, I will leave it with that, and yeah, so that's it.